Our next speaker is Dr. Elizabeth Basha, who is Associate Professor of Electrical and Computer Engineering at the University of Pacific. She is an alumna of Pacific, having earned a bachelor's degree at Pacific's Computer Engineering program. She earned her MS and PhD in Electrical Engineering and Computer Science at MIT before returning to Pacific nearly 8 years ago. She teaches computer architecture and robotics, and her research focuses on the intersection of robotics, sensor networks, and the environment. Today she will discuss the notions of robotics and autonomy, and the current use of robots in many facets of everyday life, and the prospects and limits of robotic technology. So welcome, Dr. Elizabeth Basha.
Hi, thank you all for being here. Thank you for the introduction. Again, not exactly what I'm going to talk about because, again, made my slides after I had to turn that in. But I am going to talk a little high level, touch a bunch on a bit of robotics and some of the issues with robotics to sort of get us all thinking about that side of the autonomy part of our question. And I'm going to take advantage of PowerPoint to show off lots of fun robot videos because that just brings me joy. So to start, I want to think about what actually is robotics and get us discussing that. And so let us look at one possible example. And so you may or may not look at this and understand if it's a robotic or not. And I would argue that this is not a robot, but it is automated. And so when we're talking about automation, we need to be really clear where we are on that spectrum. And so we have something like this system, which is delightful, but is only an automated system and doesn't have any sort of intelligence or actions that involve the world, right? So to make it more of a robot, we really need it to sort of be smarter about how it deals with its issues, to actually sense where's that cereal bowl when it goes to pour the Cheerios in, and align that cereal so you don't actually have this exciting adventure that we all saw here. And so that ability to sense its environment and act on the environment that it's sensing, that would then make this more of a robot, right? We can even talk further and then talk about what it means to be an autonomous robot, right? So we have machines that just do simple things like this. We have robots that actually look at their environment and act on their environment. And then we have autonomous robots that are actually making decisions about their environment without human intervention, right? So when we're looking at these questions about artificial intelligence and autonomy and people, we really need to define where we are on the spectrum and which part of those we're actually discussing. And so that's one thing I wanted to have everyone keep in mind. I also want us all to be a little leery about, sorry, YouTube didn't love me, so we have to go back and forth. What we see as robotics and the actual reality of robotics. So Alexa was pointed out. We all see the lovely marketing videos of Alexa, right? Yes, it is not a robot, but it makes a point. That is an autonomous system, right? And we all think it's wonderful according to Amazon and the Amazon marketing videos. But then we see reality and we experience the joy that is talking to Alexa. So I just wanted to know for the Super Bowl what the team colors were so I could dress appropriately for my team. Well, I mean, I know my team. I didn't want to dress for the other team. And Alexa could not help me. Right? That's a very simple question. It should be relatively straightforward for Alexa to answer that question, but it could not answer that question. And likewise, the people who end up yelling at Alexa to stop their music and it's just continuing to play, like that's the reality that we're seeing. And yes, we can get past those sort of issues and bugs, but the idealization of that reality through media and television ads, we need to be careful in how we look at that. Another example of that, for another fun YouTube video, is sometimes sometimes we see these super cool videos about what robots are doing, right? So these are little quadcopters. They're playing the James Bond theme song. They have all these instruments and it looks amazing, right? You're like, oh my gosh, robots can do such fantastic things. And then we can look at, well, how does this actually really happen, right? There's smoke and mirrors behind there. And really, actually a team of some very dedicated students went behind the scenes and hard-coded every single one of these robots, right? This is not automated. There's a computer monitoring their positions, and people thought exactly where in space should this robot go and exactly how should it move in order to make this sound. But you look at the video and you go, robots are going to take over the world. But it's really a glossy overlay of the reality of what's going on underneath and how those robots are working. And part of that has to do with how robots actually see the world. So, we have our view of the world, and we often associate that view of the world with robots as well, but really robots are seeing the world a little differently. Right? And so one example, and this is a research project we're working on, this is the Calaveras River. You and I can look at it and go, that's a river, that's a bush, there's some edges to that river, but a robot can't look at that and see the same things. We need to actually train the robots to interpret that. It's really seeing this, right? It's just it sees the world as a bunch of numbers, not the pictures and colors and context that our human brains are providing to that robot, to that environment that we see around us. And so a lot of robotics is trying to get the robots to make sense of these numbers. And that ends up becoming something that is actually quite challenging, right? So making sense of numbers, yes, we have artificial intelligence that's helping with that process, but that information is noisy, right? The sensors are noisy, the data going in is noisy, and it's just numbers and math. Right? And we have to provide the context to the robots to help it understand. And so sometimes that doesn't actually work as well as we want. Also, those robots are in that physical environment. So some people are taking my robotics class this semester and really enjoying how exciting robots are. We are trying to make them go straight. That's our sole mission in life. And in this case, this is the class. So it is not full. So we're just trying to make robots move how we want them to move, and getting them to go straight and making a little happy robot dance video becomes a really complicated problem, right? So there was a lot of talking about in that one, sorry. And so we really need to realize the difficulty in getting robots to do what we want, and that a lot of it is a little bit of smoke and mirrors. Another example of less smoke and mirrors, but still interesting. So we did a research project in doing self-driving cars, training it with neural nets. I can give more details if people want. And this is the car driving around it automatically. It did 100 laps. It was beautiful, right? You could look at this and you're like, wow, that is an amazing job, robot. It can only turn left. If we tried to run that car the other way, it refused. Did we do anything to train it to only turn left? No. We gave it a whole bunch of turns. We showed it information turning right. It just, in the reality, the circumstances of the real world and how the robot works, it just didn't want to turn right. So, and that is what is interesting and difficult about robotics, is getting it to do what we want is actually much more complicated. And these are layered systems. So once you get it to drive straight, that's fantastic. But then you want it to actually, do something while driving straight. And getting it to do something while driving straight might break the driving straight. And so when we're looking at these systems, we are looking at layered, complicated systems where those pieces all really need to interact with each other to work out well. So most of the time, the robot's actually going to lose, right? The robot overlords are not coming because the robot itself will basically hurt itself. It just won't work like we want it to. And that often is very much the problem. So I just wanted to end, and I don't know where I'm on time, so hopefully this is fine, discussing the fact that we program robots, and so robots only do what we tell them to do, right? We give them the inputs, we tell them what their output should be, we tell them what activity they should be doing. And so if we start to become really concerned about the influence that robotics is having on our lives and what those robots might be doing, maybe we need to step back, pause, and ask whether the conveniences that robots offer are really worth the cost. And maybe we don't want a robot that's quite as fancy. Maybe we want, our self-driving car to just drive and not provide me, the ability to shop on Amazon while driving or call my friend or order a pizza, because that level of complexity then gives us extra complicated problems as well. And maybe we don't want those conveniences, and we really need to sort of hold ourselves back. Thank you.